Okay, so today we're going to look at the derivatives of inverse functions. So basically, this rule will apply that if f of x is differentiable and one-to-one, actually, in order for a function to have an inverse, we don't actually need it to be differentiable. We just need it to be one-to-one, but for the rule to apply below, we will need this to be differentiable. So inverse, just as a recall, is a function that when you take a function and you compose it with its inverse function, you end up back where you started with. So the way I like to think about this is that you imagine that here's your domain, and here's your range over here, and let's say you start with a value here, which we call x, and then we apply f, and we get f of x over here, and then the inverse function will basically be the function that takes you back over to x. So that's what an inverse function is. Hopefully you've seen that before. Again, don't confuse it with a reciprocal. It's not 1 over the function. It's the function that when you apply it, takes you back to x. So if f is differentiable, okay, and it has an inverse, then just for simplicity, we're going to call g of x, in this particular example, the inverse. Then the derivative of the inverse function is going to be 1 over f prime of g of x. And really, this proof follows directly from the chain rule, because we know that if I want to take the derivative of f prime of g of x, then I know that, sorry, not f prime of g of x, but f of g of x, then this is going to be f prime of g of x times g prime of x. But if f and g happen to be inverses, then it turns out that the left-hand side is just going to be 1. So, or sorry, it's just going to be x. It's always good to remember all the parentheses here. So the left-hand side just becomes equal to 1. This is going to be f prime of g of x times g prime of x. And then we can divide both sides by f prime of g of x. And when we do that, we basically are left with this formula over here. So the natural question is, well, how is this useful, and how do we apply that formula for the derivative of an inverse? Well, let's do an example. Let's suppose that f of x is equal to 4x cubed minus 1. And what I want to do is I want to find the derivative of the inverse. So we're going to let g of x be equal to the inverse function, and I want to find g prime of x. Okay, so we know that g prime of x, based on the rule on the other page, is going to be 1 over f prime of g of x. So we need to know a couple things here in order to apply this formula. First, we need to find f prime of x. So f prime of x is just the derivative of f of x, which is going to be equal to 12 x squared. And then we also need to find g of x in order to make this work. So the way in which we find g of x, remember g of x is the inverse, is that we write our original function, which is going to be y equals 4x cubed minus 1. And what we need to do is we need to switch the x's and the y's. So if I switch the x's and the y's, and then I solve for y, that will give me my inverse function. So we're going to add 1 to both sides. And again, this only works if the function that we're dealing with is 1-to-1, but this will leave us with y equals the cube root of x plus 1 over 4. So this is our g of x. So that means that if I want to find g prime of x, then this is going to be 1 over f prime of g of x. So this is going to be 1 over, so f prime is this function over here, so that's going to be 12. There's an x squared, so instead of plugging in the x, I'm going to plug in the x plus 1 over 4, because that's going to be our g of x, which is this value down here. And we're squaring it, because this, remember, this is to the 1/3, and then we're squaring that. And that will just simplify, and this will be to the 2/3. So that's our inverse function right there. Now, you might say, well, couldn't we have just taken the derivative directly once we found g of x? And of course, the answer to that question is yes. We know that g of x is equal to this. We could have applied the chain rule directly to this function over here. And if we would have done that, that would have left us with 1/3. And then this will be x plus 1 over 4 to the negative 2/3. And then we take the derivative of this x plus 1 over 4, which is just going to be 1/4. And if we simplify this thing, this is going to be 1/12 x plus 1 over 4 to the negative 2/3. Or we could have even wrote this as 1 over 12 x plus 1 over 4 to the 2/3 down like this, which, as you can tell, that is the same thing that we have up there. So the natural question that we need to ask when doing a problem like this is, what use is even having a formula like this? I mean, when you think about it, it really doesn't make sense that we have this special formula when we could have just found the inverse and then, taken the derivative like this. And that would be correct. But one place where this is actually going to be quite useful is places where you don't have an explicit formula for the inverse, but we can find it at a particular value. So let's say I have something that looks like f of x equals x plus e to the x. And what I want to do is I want to find g prime of 1. Okay? Now, if I were to try to find g prime of x, or I should say find g of x directly, this is going to be very difficult, if not impossible, because if I try to swap the x's and the y's, have something like y plus e to the y, we're going to run into quite a few issues here, okay? It's going to be really hard to solve for y. But we can actually figure out what g of 1 is. So to find g prime of 1, well, that's going to be 1 over f prime of g of 1. Okay? So how can we find g of 1 without necessarily using a formula here? Well, we can kind of guess and check here, because g of 1 is going to be, if I plug a 1 over here, and I have x, and then I have e to the x like this, and I say, well, what value of x gives me 1? Just by observation, we'll see that if we plug in 0 for x, we will get 1, because we get 0 plus e to the 0, which is going to be just 0 plus 1. E to the 0 is 1. So I know that g of 1 has to be equal to 0. Okay? Now, we can actually apply this formula. So we have that f of x is x plus e to the x. That means that f prime of x, which we can just find directly, is going to be 1 plus e to the x. And now we can find what g prime of 1 is, because that's going to be 1 over f prime of g to the 1. And we know g to the 1 is 0. So that's going to be whatever 1 over f prime of 0 is. And we can find f prime of 0 explicitly by plugging this in. That's going to just be 1 plus e to the 0, which is just 1 plus 1, or 2. So we know that g prime of 1 is 1/2. So even when we can't explicitly find g prime of x, or a formula for g prime of x, this inverse function formula will actually help us do that. Anyway, that is it for this particular section. As always, I hope you found this video helpful, and take care.